Awful hate. Neldridge, if you're still listening, nice job on getting that first. Hope you sleep well. Okay, YouTube's live. Now, I made a mistake where I have this insane looking 7x7 Rubik's Cube, and I tend to play with it a lot when I'm just like idly like watching a stream or something. And it takes forever to solve, and I made the mistake of scrambling it too close when I needed to start the stream, and I can't let this thing sit here not solved, so I'm just gonna like quickly finish it off before I actually get into it, because it's gonna plague me if this thing just is sitting on my desk scrambled, or, you know, not solved yet. I'm getting pretty close to the end though. I was trying to speed run it when my starting screen was up. Oh my god. It's also impossible to move half the time because the rows get out of line. Hey, it's G1. How's it going? How's your day been? I am planning to do some more abstract algebra reading though, once I can get this off my mind. Great, that's great to hear. Actually, this is appropriate to do abstract algebra reading while solving the Rubik's Cube, because we're going over the symmetric groups, right? They're called permutation groups, symmetric groups, something like that. Oh crap! I need an algorithm that I don't have memorized. Hey Anders. Oh man, there's no way I'm gonna find it on Google. Parity algorithm. Oh, I should probably actually look at this more, but I just want to be told what the answer is. No, that doesn't look right. I have it on my phone, but my phone is okay. I think we'll use this one. It's for 4x5, 5x5, but it works just well on a 7x7. I've done these algorithms so many times for the parity, but I still don't have them memorized for some reason. There we go. Now it's the easy part where it's just like solving a 3x3 Rubik's Cube. Links in this PDF don't work. All right. I'll find the chapter later. How's it going, Anders? I'm just doing this because I can't deal with having an unsolved Rubik's Cube on my desk, and I didn't finish this before I started up the stream, so. Not making too bad time though. Oh no. What's that, Jed? Have I read Danny's announcement? Oh, hey, it's solved. Oh, yeah. Okay. No, let me go bring it up quick. Unless it was from... Oh, no, looks like there's a new one. Oh, no. Looks like Dan's taking a break. I was just thinking that it's been forever since I've been able to watch Dan stream. That's fair. I hope he enjoys his rest. Bad news, I have to wait until tomorrow. Is it going to be a big milestone with the streak? Oh, and hey, Sabi over on YouTube, and hey, Joseph. So Sabi, opinion on Arkin's book on abstract algebra? I haven't read it, unfortunately. This book that I've been reading through Galleon is my first ever abstract algebra book, so I've heard time commenting on others. No, I was going to stream yesterday, Monday, but I decided against it. So I just, the only thing that changed is I didn't do a bonus stream. Oh, I wish I found this so much earlier. Hey, Phobos. Hey, Fembox. Okay. That makes getting around the PDF so much easier. Yeah, same, Anders. I literally, just yesterday, or maybe on Sunday, I found out there's a philosophy niche on Twitch. Like, and it's like almost the same as our like math niche, where they're relatively small streamers and they all seem to hang out in each other's chats. And I messaged Dan, the person who I was watching, and like we were like both just like seeing what was up. What's this TikTok you posted, Anders? Let's see. Yeah, so the person, because I feel like there's a lot of people in the chat who are interested in that. The person that I was watching is Ivan Neo, if I got that right. Yeah, that's the person. Yeah, I happened to find Impercell, and so that what made me think of trying to find it here. The person that I was watching, let me I followed a bunch of people though. Let me see. So like this person is a history and math, or sorry, a history and sociology teacher as well, who seems interesting. Sitting on, okay. Shane McInnes. Globus the Elder, Prof or Prof, Noger, Tommy, and Ivan Neo. Those people who I just found who are either doing philosophy streams or like kind of related to football philosophy. So I'll actually just type out their names in chat. I won't do SO for every single one, but it seems like a really cool niche, and I want to get to know these streamers more. So, little shout out to that like niche. I've said the word niche so many times in the last minute. Oh, and I was gonna look at your TikTok. Oh god, sorry, it's probably loud. Interesting. So Parmesan cheese actually isn't vegetarian. It's made with animals, and I guess this is a vegan Parmesan, which is even more impressive. That's cool. Actually, I have some Parmesan cheese right in my fridge right now. I'm a mostly vegetarian, which I don't. There's probably a better term for that. I only rarely eat meat, but for small things like Parmesan cheese, technically has animal rennet or something in it. I just don't really mind as much. Are these phyllo? Like phyllo pastry? No, that's just cheese apparently. Wow. It's pretty cool. So that means that it doesn't even have like actual animal milk in it either if it's vegan. Oh, philosophy. Sorry. Yeah. All the people I just put in chat are philosophy or something kind of tangentially related. Someone just posted something on my Discord now. Oh god, I need to get that up off my screen. Um, 14, they said. Oh, yeah. Nimbly bimby from tree to tree. Spetry, just here to get my praise and I will be off again. Spetry, thank you for the 15 months. I really appreciate that. I'll hopefully be doing Outer Wilds tomorrow, because I'm not going to be streaming on Friday. Or not hopefully, unless something like terrible happens, I will be doing Outer Wilds tomorrow. So, and I hope to finish it in that stream. I thought I saw Zach working on this. I don't know. Did he got an answer though? Glad to enlighten you. Yeah. All right. Thank you again, Spetry. Sleep well. I think Zach maybe worked on it, but didn't get an answer yet. One second. My tea is ready. I'm just gonna go and grab it. I need to put some honey in it too, though, so it'll be a second. Wait, Jed, what was the good news? I think you only said the bad news, right? If you're still here. Okay. Of course you're still here? Okay. I might have the memory of a goldfish, which I feel like I've said before. Okay, yeah, you said good news and bad news. You said the bad news I have to wait until tomorrow. The good news, I wonder if you're just keeping me in suspense. Oh, I get it. Okay. All right, you're keeping me in suspense. I respect it. How well do you do 14? I thought Zach found that function f is like cosine 2 pi k. Oh, I see. Now I'm hyped. F is actually cosine. Okay, yeah, so did you figure that out just now, Anders, or is that from seeing Zach's stream? Because I saw that he figured out it was cosine. I don't think I looked at how though. Hardlocked, hey. Anton's chat. Is defined through the functional right. I have no idea how this means in cosine is a solution. Okay. I can just accept that. I can't tell you I can't say that I know how, but oh, that does look a little bit like sum to product identity, does it? Or product to sum? It's funny, it's almost the exact same as the cosine one, but that's cosine times cosine. Which I guess, yeah, okay, I can see how that's cosine. Yeah, okay. I mean, I don't know. If I was doing this problem blind, I would never have noticed that, but Sure. We do need to make sure that our particular cosine does follow this condition as well. Cosine of a half is -1. And I assume any version of cosine that, like, there's potentially infinitely many solutions there. Can you also do physics? Not really. I can kind of struggle with it. Like, I'm studying electricity and magnetism, but I feel like usually people are asking about mechanics, which I am very fuzzy on. We don't really need to know its cosine. Oh, really, Anders? We might actually get a little collaboration with Zach here to work on this problem together. All right, I'm gonna hop in voice with Zach here. Hello, hello. Oh,
What's up?
nothing much. How about you?
Live with Don Does Math. Because Don's doing math right now.
Yeah.
That sounds about right. Welcome. So, and I think this series problem has been driving me crazy. I was working on it earlier, and I feel like there's something. I was following Megalomorph. If you saw his comment, I think it was the elements. So,
Okay.
where is it?
Find it.
Here it is.
I should be able to just bring up your stream. That'll be easier.
That's fine. I'll move my big fat head out of the way so you can. How you been?
I'm good. How about you? Not too tired yet, I hope?
Well. Not well. Yeah, tired's relative. I have 5 kids, so that does enough for me. As far as tiredness, my wife and I are tired all the time. It just is running gag now. To think otherwise, it's fooling ourselves. Okay, so solve for k. Interesting. This note has changed since. Originally, we were saying that f of k is the like f of x function is the cosine of 2 pi x, and I tended to agree.
Yeah, we notice it matches the product of some. When I say we, I mean Anders, when I say we, I mean just Anders. Notice it matches the formula for product of sum for cosine.
Originally, Megalomorph also did, but then I think the message got deleted because last time I was working on this, I used that assumption because I saw the same thing. And I'm trying to think about what else we can do with this. I'm reading this note here. I was able to see what Megalomorph was seeing. You get that f of 0 equals 0 or f of 0 equals 1. you solve for each case. If f of 0 equals 0, you end up with you get x equals 1/2. And f of 1 equals 2. I think I see where that's coming from. You have an x plus, you have a 1/2 plus 1/2 equals 1. So that's f of 1. And then f of 0 we already established was 0. So this is equal to 2, right? No, this would be equal to 0, wouldn't it? So f of 1 would be 0. I think that's a typo. If I'm going too fast, Don, let me know. So, and I don't know what you're seeing, right?
Yeah, I mean, I'm just watching your stream right now.
Okay.
I think, yeah, because
let me pull up LigTech.
Okay.
I find I'm not gonna. I think I'm talking too fast. I need to slow down. Oh gosh. Exact test. That's not what I wanted. I wanted. Okay. So here's the thought. You're going to calculate f of 1. The way we're going to do it is it's actually going to be f of 1/2 plus 1/2 minus f of 1/2 minus 1/2. Right? And then that's going to equal 2 times f of 1, or f of 1/2. Maybe that's what I was thinking.
And we know what f of 1/2 is. Okay.
And we know what f of 1/2 is. So in other words, yeah, this is going to be f of 1 minus f of 0. So maybe this is right. Maybe that wasn't a typo. F of 1/2 is -1 times -1. What's up, SPQ? Welcome. I'm chatting with Dawn.
Hey, SPQ.
So that means we know that it's not new page. We want new line. So that's that. Next thing, we're going to take, we know that f of 0 was 0. And the left-hand side is 2. The right-hand side is 2. How are we doing, Don?
I'm on board with this. Actually, wait, do we know f of 0 is 0?
We do. That was our assumption. We're trying to figure out which of these two
is
correct.
Okay.
We don't know yet. So f of 1 is 2. Cool. Setting y equal to 1, we get was 4f of x. So, you get a linear recurrence. This is very messy. I'm not sure what to do with it. I was hoping that cosine thing was going to work, but it doesn't work. Alas. Anyway, you have any thoughts?
I've hardly done the problems where they give you like f of x plus y, like those kind of like functional. I forget what they're called, but those kind of like.
Yeah, they're functional equations. That's what they're called.
Okay. Yeah, I'm pretty inexperienced with these, and to combine it with this really weird looking sine sum.
Yeah.
Is tripping me up.
Yeah, and that's the thing, is I was leaning into the fact that there's a cosine showing up, and it would have made sense. The other thing that I'm wondering is there a convenient way to combine these so that we get sine of f of k, and like you can use an identity for this denominator, right? This is a product to sum. So you do like cosine of, what would that be? 2k plus f of k and cosine of f of k, or minus f of k. something like that, which would just be cosine of f of k because of evenness. I can write that out. Sine of k and sine of f of k plus k, right? So my thought here, let's just close this out. We don't need that anymore. So going back to this sine of k, f of k plus f of k. That is equal to cosine of k plus f of k. And there's a 1/2 in front, isn't there?
I don't imagine it would help a lot much, but I'm wondering about doing a sum identity for the sine of k plus f of k. Just what would it look like?
You know, that could work.
I'll try doing it out in Paint here.
You can let x equals ooh. Syntax error has an idea. So if x equals 1/2, if x equals 1/2, you can let, and then y equals 0, you get the f of 1 is 0 equals 1. Let me see. You can. And that's part of the issue, is we could get both, and we're trying to pin down which of those two could work out syntax. So yes, you could. Yeah, there's two possibilities. Now, wouldn't we want... Is there any particular advantage to getting rid of f of 0 equals 0? Getting rid of that case. Still there, Don?
Yeah.
Okay. Just double checking. I didn't know if you had lost yet.
No, we're going to sum the product. I mean, we do get like a sine squared if we bring in the other sign, which could be something interesting.
Well, if f of k... Yeah, if f of... You have a linear recurrence. And you have a linear recurrence in terms of 2 plus square root 3, which doesn't feel helpful. I don't know.
I'm being made fun of for using Paint while using LaTeX.
Oh my gosh. Yeah, don't get made fun of. That's not good.
That's true,
just
though.
Too funny. That's funny. I think f of 0 equals 0 equals impossible, SPQ says. That seems like... I would like to believe that, SPQ. I seriously want to believe that. I really do. Because if that were true, what would happen is you get sine of k squared, which would be in the denominator, which would be cosecant squared k. And then you just sum of cosecant squared k from 1 to 20. That doesn't feel right. You get f of 0 equals 0. So the idea is if you let f of x and y be 0, here's what happens. The f of 0 plus 0 minus f of 0 plus 0 equals, excuse me, did I mess it up? What's a plus? That might be part. No. Plus equals 2 f of 0 f of 0. And what's that? That's 2 f of 0 equals 2 f of 0 squared, which you can then solve and get f of 0 squared, take that in parentheses, minus f of 0 equals 0. And I'm dividing by 2 as I do that. So if I divide by 2, just to be complete, my steps here. And I don't want to divide because that will eliminate a 0 solution. It's possible that I get a 0 solution. So I need to, and I don't want to divide by 0 accidentally. Yeah, and I think that was shown, Megalomorph showed that SPQ.
And this is the cheat sheet for the trig identities.
F of 1 equals 0. That would be convenient. We can use that fact. Don, I don't want to talk over you.
No, I'm just messing with some other trig identities. I'm not getting anything that's particularly helpful.
F of 1 equals 0. See, and that's SPQ. This is the thing: is f of 1 equals 2 according to the thing. So if we put x and y is equal to a half, this is what happens. We know that f of 1/2 is equal to -1. Right. That's what I mean. That's exactly what I mean, SPQ. Completely agree.
Yes, and does there exist a set E that C, the complex numbers, is included in E, that the complex numbers are a subset of? Probably, but I don't know. You can probably union the complex numbers with anything you want.
Onto that. So we know f of 0 equals 0, and that's our hope. Yeah, we know it's got to be one of two things, right? It's got to either be that f of 0 equals 0 or f of 0 equals 1. That's right. So you could do some factoring here. It's got to be one or the other.
Go to bed now, but I don't say. But oh, that'll be the day, Nikas. I'll see you later. Sleep well.
Okay, so we've got an idea from SPQ.
Oh, good.
Here's an idea. F of 1. So f of 0 plus f of 1 is equal to C is equal to 0. Can you show me that SPQ? Because that one's the. Is it because you're putting in x equals 1, 0, and y equals 1? Is that what it is? Or like something else? What are your inputs? X equals 0, x minus y equals 0, x. We chose, well, no, hold on a second, SPQ, because I'm doing that with 1/2, and I'm getting f of 1, f of 0.
Yes, I think I've heard of like
JK.
Complex numbers that have like
no, I just saw that.
Instead of just I, it's like
I,
J, and K. Like you can extend the complex numbers in that way. Maybe that's what Professor was talking about. I don't remember exactly. Yeah, I'm not sure exactly though.
That might have been part of the problem.
Yes, central. That is a new low.
Even so, f
no,
of
we're going
0 we said was
together.
1,
I'm not contributing that much so far though.
So if f of 0 equals 1, then f of 1, yeah.
Oh, a 3 watch streak. Thank you.
So choose x equals y equals 1/2. Huh. 0, 1. Go ahead, Don.
No, sorry. I'm reading what Zone just put in your chat.
Yeah, I'm trying to process all of that at the same time. Where was the original prompt? So we get Megalomorph is saying f of 1 equals 2. I'm starting to disagree with that because we said that f of 1 f of 1 that's -1, right? And then we got 0. I said f of 0 equals 0 here. So I'm still getting that f of 2 equals, or f of 1 equals 2. But I'll take a look at zone rangers.
I followed Zone Ranger's thread. If f of 1 is not 0, we could say that f of 0 is 2. We'd have to divide out an f of 1. Actually, no, I'm sorry, 1. F of 0 would be 1.
I'm getting the f of 0 equals 2. And this is the difference, right? We're trying to, if I follow Zone Ranger's reasoning, let x equals 0, or x equals 1, y equals 0.
Oh, yes, and if you're still here, that boy Randy
here,
is saying
we're letting x,
it could be quaternions, which are denoted
x equals 1/2
by h from Hamilton.
And y.
I typed it out there in chat. Thank you, Randy. I mean, probably you could program this one.
So f of 1 plus 0 minus f of 1 minus 0, or plus, it's a plus. That's not doing that. 2 of f of 1 and f of 0. We established that f of 0 is 0, right? So that means that f of 1, 2 of those is equal to 0. And so f of 1 equals 0. Isn't that a contradiction? Doesn't that say that this is a contradiction and it can't be done? Yeah. Can't be the latter because, yeah, f of 1/2 is equal to -1. That feels like a contradiction then, because if we're assume we write this out like a quasi paper. That's what I feel like I'm doing here. I'm writing a paper. So if we assume, probably organize it like one. Make a document section. And then we're going to section solving. So trying f of 0 equals, what was our assumption? F of 0 equals 0 first. So if we try that, f of 1 gives us contradictory results, and so we can't let that happen. F of 1 equals 1. So we put that in here. Cool. This is the contradiction. I'm just doing f of 0. Compare the two equations. Let y equals x, and then let y equals minus x, and compare the two equations, huh?
Yeah, we only care about integer x's, I'm thinking, Jed, which might help us, because the only problem comes from a sum.
Yeah. And thank you so much for the follow. We just had another follow. Welcome to the stream. Glad you're here. If you want to introduce yourself, you may. But welcome. Don, how are you doing?
I thought of what Anders said, and I'm not quite sure about like the last step where it'll involve dividing out an f of x. But if you can do that, you would get that f of 0 is 1 as well.
Right. But then Zone Ranger is saying, well, let y equal x, and then y equal minus x, and compare the two equations.
Oh.
You could try that as well.
I would show that it's potentially even, I guess, if we think it's cosine. I mean, I'm not
sure,
see but that helps. I don't know.
Yeah, I was going to say, I don't know if that, well, we can try it. F of 0 equals 1. I'm sorry, it's f of 0. I can't type today. Forgive me, I've been going for quite some time. Thank you, Alcatel.
I almost wonder if we could work more on the sum and try to, once we get something that's maybe like try plugging in some k's for the sum and seeing if we can figure out some kind of like periodicity to make some of the f's find out that they're equal to each other.
Yeah, we could do that.
I feel like I'm going around in circles with this functional equation stuff, which I'm really not familiar with. I might try that.
Okay. All right, so we've got a whole bunch of stuff to try.
Cool. I'm now convinced.
So let's go.
Streams are centers for mom ordering food instead of cooking. Oh, really? Well,
y equals x.
I'm going to take that as a good thing. You're welcome, Waffle.
So
individual parts is number 14. I'm showing it now.
It's f of x.
Which step? Just this last one where you divide out f of x.
F of x minus x.
Because f of x could conceivably be 0 for an integer.
F of x.
Don't divide?
Which means
just factor.
That f of 2x minus f of 0 equals 2 f of x squared, eh? Now that certainly looks like a cosine function if I ever saw one. But again, we get contradictions. And I don't know if the y equals x part needs to be here in this section or not. And see, that's what we thought, right? Alcatel, we agree it's even. Yeah, I think that's the idea. But originally, that's what we thought. Oh. Just a second, chat. I gotta take a message real quick. Okay, I'm back. I love the team collaborativeness of this problem, by the way.
Yeah, this is fun.
This is fun. We gotta do this more often, right?
Yeah, like I think I've done it with Pen Center once, and like I think that's it.
Right. I think this could be something that would be good to do every so often.
Yeah.
I could be. Now, what you're talking about Alcatel. I think we'd want to do this down in the f of 0 equals 1. So let's go to the other section. I think that's where we should have done this in the first place. If y equals x, then we show, I see. Right, so 2f of 2x, 2f of x.
Sorry, I'm like talking mute on and off on Discord here.
Minus 1.
We can use a trigger identity. I think Zach has tried it,
f of 0.
And it didn't give anything that much cleaner, so I'm just doing it straight to the original thing. You can. I don't know if it's going to help. I'm hoping to... If we can get an answer that's this clean, there must be some cancellation somewhere.
It literally is 2 cosine squared
So I'm trying to not worry about what f is right now, and just seeing if I can figure out what the cancellation must look like, and then reverse engineer something with f.
Right. And that would mean that f of x equals, like you'd say, 2 cosine 2 pi x. Which is what Megalomorph got the first time. And we were, I just, somehow so that gets rid of the first case. And then, what do we got? Is there any other notes I missed from Alcatel? So, you'll still get the cosine AX's solution, 2 pi k, great. So,
in addition down there, because I wasn't paying attention, I guess.
The next thing would be, now that we've established f of x is equal to cosine 2 pi x, we want to now solve the series, evaluate the series. Our series is from k equals 1 to 20, isn't that right? And it's the reciprocal of...
Yeah, true integration by parts. Cosecant goes with sine.
1 over sine k. Sine of k.
No way. Cosecant squared of k is the same as the sum of integers? That's a crazy thing. I'd never heard of that. That's cool. That's true.
This feels like you should use an identity. Like when I tried this earlier and I tried to use... Yeah, that's what I was going to do, Alcatel. That's what I did earlier today. Since this denominator is equal to the fraction of 1/2 left, right, cosine of k minus k plus 1 minus cosine of k plus 1. That means that series is this stuff. I agree. Completely agree with you 100%. That's what I had earlier today. Something along those lines. Cosine of 1 minus. Now we probably would want to use a what's it called? The conjugate here? Is that the right play? I literally got to this point earlier this morning. You could use a conjugate and multiply by cosine 1 plus cosine 2k plus
okay,
1
yeah, I'm on mute.
On the numerator and denominator. I don't know if that will simplify.
What a crazy identity.
2 cosine squared things.
That's a slightly different looking one.
I also don't know if we should try to break up this cosine 2k plus 1 like by some indifference, but that might give us the same problem we had before. Right. The two terms in the first two terms of series opposite in sign. Good question. How are you doing, Don?
I'm still just posting the summation more. Integration by parts pointed out this identity that might be helpful. I've never seen it before. It's kind of crazy, but it seems true according to Stack Exchange.
Mm-hmm.
I'm still trying to work out if that can be helpful here, though.
1 to n-1 of the sine squared. But here's the thing. That's a... You can recognize the pattern. Yeah, I mean, we can write out the stuff.
I guess we don't expect an integer answer, though.
True, but I wonder if 2 over cosine 1 minus cosine of 2, so that'll be 3, plus, we can take all of this, add it together, 2 and 5, and the last thing is going to have a plus cosine of 20, cosine of 31.
Algebra, you get C.
Close that out.
Huh.
And I don't see anything helpful there. Cosine of... Oh, dang. Oh, dang, you're right. Thank you.
E waffle when there isn't an E.
Right,
I respect it.
2 pi k. Yes. We need to actually put 2 pi k. That might be part of our problem, actually. Because that should include a 2 pi k. Yeah. So yeah. And that it's C. Hey, integration by parts. What's up? Yeah, no, it's good. I'm doing well. Glad to have you around. We're just you're probably catching up with Don, or you're helping out Don as well. We're trying to co-work on something, and this. You say it's C. I want to believe it's C. I want there to be some kind of telescoping. That's what I want. It's really what I want, chat. I agree it's C. Good heart, let's see. Zone Ranger agrees it's C. We decide that cosine 2 pi k is equal to 1. Oh, that's right. It's 1. Yes, we did say that, didn't we? So that's the problem. So
yeah. That's really similar to this one if we know it's 1. I remember how it works.
Yeah, cosine. So cosine of 2 pi k. That's where it is. I messed up. Once again, that's what happens. k+1. Okay, what we had was correct before. Never mind, chat. Don't mind me. Right. So that's always 1 because Yeah, we said that. I think I did. I remember saying that earlier in stream. Cosine of f of k. Hang on. It simplifies to cosine f of k.
I'm if I can quickly find the video where I did a problem similar
I want to believe that.
To this.
I just need proof. I need something.
Because this feels so familiar.
Formula. Sine product formula. What does that say?
Oh wait, that's not the right.
I got to remember. I rederive these every single time I use them.
Oh, is that the one I was thinking of?
So,
no.
when you subtract these, you get cosine of 1, which is what we got.
That one.
And cosine of 2k plus 1. I don't see any error. Do you remember what your partial fractions gave? If we decompose this back a few steps to go on a way out of it. Yeah, not a good way for it. I did that sometime earlier in stream, and I don't think it ended well when I did it. That's what I remember.
It's scheduled to start Anders in 3 hours and 40 minutes.
Well, chat, we're at the 3.5 hour mark. Yes, and then if you use sine of that, yes, and that's what we've got here, right? We've got the cosine of a minus b. Right, so in a, this is going to be showing all our steps here.
Person who posted it does have the solution. They said they can post it. We can keep working on it before we actually like look at the solution though, if you want.
Yeah, I don't want to look. Well, here's the thing. If there's going to be some tricky like identity we're supposed to use, I agree. Integration by parts is saying that to apply the product formula, and I'm doing that. I'm failing to see like where the that doesn't feel helpful. And perhaps I'm wrong. I'd love to be wrong. I'm happy to see the solution though.
They're still working on it.
Okay. Right, so that's even. Yep, we agree. Then via logic using the identities, I concluded the answer is C. Okay.
Venlox, I think they managed, I wasn't following, but they managed to figure out that f of x is cosine of 2 pi x. So I've just been accepting that.
And the cosecant summation. And that's the thing you posted, right, Don? That cosecant summation?
Yeah.
Cosecant squared. See, that's the connection I don't see. I wish I could see it. I want to see it. Reach the series, you can't do it. You got to recognize the pattern. What simplifies to, we can't calculate it. Right, that's what I mean. I think this series is sort of worthless. But I got to recognize what pattern. Oh, that pattern. Okay, so this is so there's an identity here. This is the key step. That cosecant. Okay, it's a pattern I'm not familiar with, but that's the triangular numbers. This thing here, huh? But K and N aren't related, are they? I want to see if we have something. Interesting. So there's actually a way. So this is the way to do it, huh? I used cosine a minus b equals 2. Right. And in some ways, that's sort of what we were doing earlier. Right. That's exactly the same as what we had before. Proof. Okay, so there's a proof. That's really interesting. So this is a proof I've not seen before, but you can factor out an m. And you write this. You can write.
Well, Sam posted an idea about partial fractions. I don't see how you do it though. I don't think I got anything meaningful.
Sine squared of x is equal to x
I
plus
like the idea though. I think it'd be really
squared
helpful to try to get a telescoping series, but
for all n and z. That's an interesting identity. I need to really dive into that because I'm not sure if I believe it. But if we assume that's true, then we just sum across everything, find a common denominator, multiply by m. This thing we established is sine of n squared. Huh. You swap the order of the bounds. That's really interesting. That just turns into sine of n squared. Yeah. Well, I'll be. That's really interesting. So found that f of k equals 1 where k is a real number. Yeah, and I believe that. Huh. That's interesting because I would have expected that to be for integers. Integration. Okay. And this one here, I'm doing a little bit of a. This is sort of an interesting series. Hello, welcome. Ipsum Wacky Stove. Welcome to the stream. Can agree on that one. Yes. Welcome to the stream. Welcome on in. How are you doing today? We're working on a problem with series. I've been doing a little bit of a co-stream here with Don Does Math. You can say hi to Don.
Ipsum.
Give you a shout out too.
I was on mute. Hi, Ipsum. Sorry about that.
So I think you can't solve a simple math question. Okay. Let's see if we can help you out. I think we've just about figured this one out. Break isn't at 3:30. Yeah, it's not quite time for break, but we can take a little stretch break if you want. We can't take too long of one because we're on a bit of a time crunch. We've got to make this before 6 p.m. Pacific before 7 p.m. Mountain Time, 6 p.m. Pacific. There's going to be a class with Penn Center with complex variables. So I want to make sure that we make that. And with the time we have left, we can make it, but we have to take a very short break. So I might take a quick 5-minute breather, take a quick walk around, and then we'll come right back. Drink. Oh, we did take a break at 12. Yeah, no, I did take a break. I just hadn't I pause I don't pause the stream. Sorry, I didn't update the next break. Oh, you're looking at the thing on the oh, the ticker. I get you. Dang it. Oh, you forgot. So yeah, if you want to throw a question in Discord, feel free. It'd be good to like take a quick 5-minute stretch break if you haven't had a break. But okay, we're gonna
Do you say that
save
you
that.
figured out the problem?
I think I have, ish.
Okay.
So I think chat helped me. So the key insight here is that cosecant squared. So this cosine thing is a dead end, first of all. I think. I'm going to cancel all that. Where did... So the sum of cosecant squared is n times n plus 1 over 2, which is your 20, right? I think n is 20 in this case.
Yeah, I'm confused about the whole k versus n thing as well.
Yeah. And so how... So that's the last thing here. How to apply that last identity, and then we're going to take a quick break. At least I will. Yeah, 20. Hang on, because you're summing.
Like, we can't split up a product with a summation, right? Like, we can't do it as sum times a sum. Yes,
No,
that makes it a lot harder. Sorry,
I think no, you're fine. I thought I had it integration by parts.
I
know
probably should
somebody else is
give it to
saying something
Wolfram.
to
I didn't
Alcatel. I
give
think
Wolfram
you
the
were saying
entire
something
problem.
as well. Help me. I just don't know how to apply this because cosecant squared k, the sum of that. I agree. How am I trying? What am I trying to say? The sum of this from q equals 1 to some like for some k equals 1 to q
Does it numerically?
is equal to q.
What the hell? That's
q minus 1.
It's not quite an available answer.
1 over 2, right? Is it sine of that? Okay. Yeah, I was trying to figure out like you had there's a page that I saw with this identity. It was this one, right? Because I just can't connect how it's used.
I'm looking at the answer right now.
Is it this thing? I would not call this one well known. I'm a teacher. Yes, I am. I teach at a college. Or I used to. I'm currently a PhD student, but I was formerly a teacher in K-12 Ipsen. That's right.
I may have peeked at the solution, and they do a completely different thing.
Oh, really? You may have peeked at it. I'm okay with peeking at it if you want to.
Oh, I mean, like, if you just look like in the first image that the tech bot rotated, look like halfway through. Just look, they multiply by sine. Oh, sorry, it's over in my Discord. That's where they posted
Sorry about that. This thing?
The one above that.
Okay. So.
And then like halfway down, they multiply the top and bottom by sine of 1. They do some crazy stuff.
So we ended up with this part right here, sine of k plus 1. We agree. And then divide by sine of 1. Oh my gosh.
Yeah.
No. Oh, boo. Boo. Okay. Well, I guess that's fine. All right. Multiplication shenanigans.
That's hard to notice.
Yeah, sure. I think integration by parts. Does this work? I think this is a good way to do it. But to know to write sine of 1 like that, I'm going to just... it makes me icky inside.
Mm-hmm.
Yeah. And then you get cosine of k plus 1. Yeah, that'll do it. Cosine, sine. And then you have to do a bunch of identities. This will be a product sum. Yeah. Okay. Well, Don, I think that'll work.
Yeah, unfortunately.
Unfortunately, yeah. I'm a little miffed. I don't know that I would have ever saw that.
Me neither.
It's the classic make a 0 trick, right?
Yeah.
Or it's like the 1. The 1 and 0, because you have the identity both, here.
Yeah.
You got both of them in there. Yeah, it felt like there were some identity shenanigans. Oh, that makes me angry.
Just the wrong train of thought. I mean, maybe there's still an identity way still, but I definitely don't see it.
Sure, I can't see it either. Okay, well, there you have it. We got it. Thanks so much, Don. I appreciate it. I shouldn't say we got it. We had some help, but I appreciate it.
Yeah, this was fun.
We'll have to chat and do this again.
Sounds good. I'll talk to you later.
See you later. Bye-bye.
Okay. Maybe I was being a little bit like more quiet there. I didn't want to talk over Zach too much. And I just didn't have that much helpful that I could contribute, to be honest. I wasn't really sure what I'm doing with that problem. Let's see if we can... This person would like want the thing explained to them. So I don't quite understand exactly how we get to fx being cosine 2 pi x, but if I just let's follow the rest of the work, what happens? So once you can break it out into cotangent k minus cotangent k plus 1, it's this becomes a telescoping series. Actually, this is a bit of a jump from this step to this step. How do they do that? They must do a difference identity. Okay. Oh, okay. That's where they explain it. No, never mind. The continuation of this step. They get a common denominator, it seems. Oh, and you notice that's a difference identity? Oh. Oh, you're kidding me. There's a lot of... tricks going on here. Let's see if they need help on a specific part of it. In the meantime, I want to look at this function part. They're just saying let. They don't say why you should suspect this thing is cosine. They just say suspect that it's cosine. Oh my god. So probably really only had to be able to work out that if x or k is an integer from 1 to 20. Yeah, I don't know that this is a unique solution to this functional equation, but cosine definitely fits the bill. I was wondering if like an exponential could or something when we were first talking about the problem. I'll put my tea away. Oh god. I'm trapped? Okay, no, I'm good. Or my mug away, not my tea away. My tea is already away inside my stomach. We could ask this person. Oh, it is a JEE question. Interesting. So someone in the YouTube chat asked if it was, and I said, it's not as far as I know, but I'm not sure. Um, Man, how can we show that? Um, they want you to figure it out is that it matches the product to some identity for cosine. Actually, prove it has to be cosine. Named x, but none of them really helped that much as far as I know. It's not the right channel. So this person, like, I feel bad that I don't have a very good explanation for, like, I think that step, this, to me, this step is the hardest step, even including this whole sine of 1 over sine of 1 multiplication thing that you do. I still think this cosine of lim to x part is harder. They're both pretty much completely out of thin air, though. Maybe the sine of 1 over 1 is even more out of thin air, but... Give you something to draw really quick. You should draw Zach, but like he's holding a sword, but instead of a sword, it's like a big thing of chalk. You can try it? Okay. I'm sure it'll come out better than anything I can do. Technically, it should be neither me nor Zach, but you know, this isn't. I'm not Don does grammar. Oh, let's see what this person says. Oh, okay. I didn't realize that you were watching the stream. um, yeah, I feel bad because this problem, it just expects so much of you. Like, this seems like something where you have to do a bunch of these problems to figure out the tricks they like to use. And that's the main hope of being able to do a problem like this. Like, both me and Zach don't know the tricks that they use for this JEE stuff. And so we just both got stumped on. I mean, including like a bunch of people in chat. So, yeah, I'm really sorry that I don't have good advice for you on this problem. Besides the general advice of just learn, or at least try to learn what tricks they like to pull and just remember them. Yes, that's really crappy advice though. So sorry about that. I mean, it's like the best advice that I can give, but if there's like an identity or something like that that you say that you don't quite get, then I can try and explain like that part of the problem more. But the step of figuring out that it's cosine of lim to x and multiplied by sine of 1 over 1, I can't tell you how to spot those on your own because I just don't know. I couldn't spot them. So yeah, I'm keeping it on Discord in case you type anything else, or feel free to type in chat too if you want. But if I don't see anything else, I'm gonna move on to just doing some studying. But yeah, I guess if you have anything else to say, please feel free to say it. I'm just not sure what else I have to say without hearing more. Art stream? I don't think I can do an art stream. I don't know how to do art. If you did that, that'd be cool. Cult random streamers into doing art streams. Do you actually? Oh, cool. I have that little art channel on my Discord where I post the drawings that I've done that people have redeemed. And it's not good. Whoa, excuse me. The works of the gods you post. Yeah, what's up? Did I draw? Was it Tree Stump Me? Was that the last one? Oh yeah, I posted the one that you drew, or the one that you redeemed of your cat. And that same day, Thunder made me draw me as a tree stump. That's right. Oh yeah, Randy. I feel like I've seen you before. Like you're not necessarily new, but if you didn't know, Penn Center is doing this abstract algebra reading group, and I've been reading along with it. Well, I'm pretty far behind on it. Like they're probably going to move on to chapter 6 soon, and I haven't even read chapter 5. But yeah. So this is one of the things I've been studying to fill in the free time on the stream while I would see someone have a math question. I've also been doing my own reading group on electricity and magnetism, but right now I feel more in the mood for algebra. And if you're interested in more math streams in general, let me shout them out. There's a bunch in case you're interested in more like math streams. Zach is a real person, so this may turn out horribly. You can only draw fake people. Oh. I mean, I can't draw a real or fake person, so. My friends are algebra guys. I'm like the one person who prefers analysis. Oh, really? Well, I'd say the person I was just in Discord with, each of the 2i Pi, who's in that list, or also Zach, who we're talking about now. He's a PhD student studying analysis. They must be figments of the imagination. Yeah, I majored in applied math. I much prefer the applied side of things, so that the algebra stuff I haven't. There's some neat things in there, or like neat proofs, but I'm studying it more because I think it's good to know rather than I'm super enthusiastic about it and want to know everything about it. So it's pretty early on into group theory. But what we've learned about like subgroups and cyclic groups, and I'm just studying on permutation groups, and then we'll get into isomorphisms. Lagrange's theorem, all that good stuff. Oh my god, I all of a sudden got super tired. I'm not planning to go for super long today. Could have just like woke up on the wrong side of the bed or something where I'm just like not feeling as good as I usually do. That's what I think of when I think of pure math. Yeah. Same here. I don't like I've heard a lot of the terms for like higher level math, and I don't have a very good understanding of what they all like do, what problems they deal with, and things like that. But algebra does seem like at the heart of pure math. I've heard Zach describe it as like the abstraction ladder, where people like pure math like to talk about things as abstractly as they can. And algebra is, well, I guess you can go beyond algebra with like category theory. And I think I've heard of something called like conglomerate theory or something. I need to reread this definition. One-to-one and onto. Okay. So we get these matrices where we have basically the indexes in order for the first row, and the second row is what each one of those indices gets assigned to. So in this sigma permutation, if you gave it a 1, it would give you a 2. If you gave it a 2, it would give you a 4, and so on like that. And you can compose these permutations. If you have gamma of sigma, you would go from right to left with these permutations. So if you gave this composite function a 1, we'd start with the sigma permutation and say this one gets assigned to 2, and that 2 now gets assigned to 4 from gamma. Okay. I've already read this stuff, but it's been long enough that I need to reread it. And we introduce symmetric groups. S3 is the set of all one-to-one functions from 1, 2, 3 to itself. You take this set with function composition, and it's a group. That's right, and they gave this trick where if you, in this initial listing of 6 elements, there is no beta times alpha listed. So if you're asked to compute what, wait. Well, okay, I guess they're doing the reverse direction. If you start with alpha squared beta, you can use the associativity. How do they go? Here they use beta. Aren't you using? Oh, they use this relation to get another relation. If beta alpha equals alpha squared beta, they can start with, they can use this to show that beta alpha squared equals alpha beta. Interesting. Okay. Hey, critical, can constant be pivot? I'm a little confused by that. You're only working with matrices of constants in general. Like you don't have any variables in your matrices. You can have a variable in a matrix, I think. Well, I mean, I guess you sometimes have a. I see with the parameterization. I shouldn't say that. It's a little bit. Can you post an example of what you mean? Well, I'm thinking you're only ever going to have a constant that is a pivot. Like, I mean, I don't know if a pivot has to be one in particular or if it can be any number, but you're never going to have like a variable x, I don't think. You're asking if that one's a pivot. Oh. I think I see what you mean. Is this an augmented matrix where this last column is the solution column? Yes? Okay. In that case, this is not a pivot. This would be like 0x1 plus 0x2 plus 0x3 equals 1, which is the same as saying 0 equals 1, and you would say there's no solution there, or, you know, it's inconsistent. So yeah, you wouldn't call it a pivot, I don't think. But there's a different context if that wasn't an augmented matrix where that would be a pivot, which, I mean, it could be some weird technicality we can still call it a pivot. But in like an augmented matrix, I don't think you would ever call that last column a pivot. I don't think. I mean, you've heard me say before that I don't know linear algebra that well, but from my recollection, you wouldn't call it a pivot. Prove the Riemann hypothesis. Hey, Moses. You first. We got another problem from the same person as with that functional equation problem with sines. Yeah, critical you can. I think I'm gonna try with this one first. So if you want to go ahead and post it and I'll at you when I can look at it. Oh, Obi. Thank you very much for the raid. I can't talk. How's your stream? Thank you, Moses. I just brought this problem up now. This person posted another problem before this that was super tricky, so I'm not that confident that I'll be able to figure out this one, but let's at least try with it. Yeah, Fembox. 0 is less than A. So that means A is positive. B is less than 1, and potentially negative. Worked on a couple of problems, and you're feeling pretty tired. Just gonna mess around. Fair enough. I'm feeling the same. Like I just like woke up today and felt like, I don't feel like being that active. What is happening here? It's been rainy here. I don't even have that excuse. Wow, this turns into something with E? What is this? Huh. E pops in least expected places? It does. Okay, is there some kind of series? What's the series for arctan? This is arctan though, Fembox. Do we have the same rules here? You hate books that have typos? Oh, that's the worst. I don't think we can use that though, Fembox, can we? What? It doesn't tell me the series? Because these are arctans here. Arctan A, arctan B. Is it a common Taylor series? I don't think it is. Oh! What? Does that work? We gotta try that. I thought you were just misunderstanding. I never doubt Fembox. Because that's really cool if that actually is going to be helpful here. But let's see. Tan A plus tan B. One minus tan A times tan B. Okay. So you get just A plus B over 1 minus AB. And we take the thing from the initial part. Arctan A plus arctan B. Pi over 4. Tangent of pi over 4 is 1. We multiply 1 minus AB over. I don't know how much more we want to do with that. At least do that. Might be able to factor it at some point. I guess we'd have to stipulate AB doesn't equal 1. Which I think can conceivably happen. Yeah. So now what? When I first saw this problem, I was thinking that we could split it up into a series of just A and a series of just B. I don't know that that's really helpful, though. It would be nice if we could write these as... Well, would it be nice? I was thinking it might be nice if we could write it as like A plus B to some power and then minus whatever is left over, like whatever's spare. Like saying that A squared plus B squared is equal to A plus B squared minus 2AB. I don't know that subbing this for that gets us where we want to go, though. Gold series expansion? Yeah, I don't know what the series is for... Actually, oh, that's where E comes from. We do want to split this up into two different series because E to the X as a series is the sum. Oh my God, what is it? It's literally X to the N over N factorial from N equals 0 to infinity? And that matches exactly with the A's and the B's. Yeah, that... Okay. That's good call, Gold. Yeah, okay, I got the series for E right. We don't... Oh, you're right, Pinbox. We do not have the factorials. But we could say this series above is from N equals 1 to infinity, A to the N over just N. Ooh, it's alternating though. The first term is positive. We're starting with an odd number, so negative 1 to the N plus 1, A to the N over N plus. Okay. And we could put these back into the same series as well. I just thought it might be more helpful to have them separate. Minus 1 factorial on the top. Yeah, that's... Territar, are you trying to prove a trig identity? No, the problem is what's in the lower left. We use a trig identity to help figure out how arctan of A plus arctan of B equals pi over 4 is helpful. We do have this relationship here. And I feel like this must be where the n-1 factorial comes from somewhere. I don't know how we show that though. Like, the other issue, well, okay, A and B are real numbers, but n is an integer, so we're okay on the domain of the factorial. We don't have to use a gamma function. Can we somehow solve this for just A or just B? Yeah. We could say that 1 minus B over 1 plus B equals A. If we factor the A out from those two terms. Now, if we plug that into this A, does anything good happen? Common denominator. B to the n times 1 plus B to the n. Over n, right? So I could be completely going off the rails here, but we end up with just 1 plus b squared to the n over n1 plus b to the n. I don't know if that really helps. Hey, Stelly, I think I was saying. Me and your friend passed the test because of your help. Oh, hey, thank you so much for like letting me know. Congratulations. Territar is asking if that infinite sum is ln of 1 minus x. Is it? Oh! Maybe we don't want E, we want ln. I don't have to pay for college because of your help. Oh! That's even better. Holy crap. Huge congrats. Best of luck with college. Yeah, this is exactly the series for ln of 1 plus x. That's a good call, Territar. Yes, Sally, that makes me super happy to hear. I really appreciate you, like, coming back and saying that. Oops. The wild dawn was flabbergasted. So we can even back up to this step and put it right into ln. Or the bounds. Should actually care about the bounds. N equals 1 to infinity. Perfect. So we can say this is ln of 1 plus a plus ln 1 plus b. What form do our answers have? Ooh, we have to get an actual number here, though. Yeah, this is a pretty hard problem still. I don't blame you. This seems like we need to do this, right? So if you have 2 logs added, that means you can multiply the insides, right? I don't know why I'm... I feel like I'm getting my identities mixed up now. Log identities. Okay, good. You can multiply the insides if you have 2 logs added. One plus 2ab plus ab. That's not good. Wait, what? What the hell did I just write? 1 times 1, oh my god. 1 plus a plus b plus ab. And a plus b plus ab is 1. It's ln of 2. Bam. Oh, that's a cool one. So I'd say the answer is A. And for the person who posted the question, if you, I wasn't really explaining what I was doing because I didn't know if it was going to be helpful. I can try and go back and explain it, or tell me if you have a certain part that you want me to talk about more. I completely forgot about the series for ln looking like that. Your 2 brain cells already fried. Just came in for the music and ASMR table touches. My birthday, hell yeah. I got those in spades. Finished his act by, you can confirm, oh, but you can confirm it looks nothing like him. Excellent. Maybe I'll type out a response for this person. Actually, I think I'm just gonna get a screenshot of the whiteboard and I'll put like a quick explanation in text. Give me 1 second. some identity and plug in arctan A and arctan B to get something, to get a relationship or a full relationship for A and B. This exact thing, A plus B plus AB comes up later in the problem. The other big thing to notice is that if you split up the infinite sum into a series into two series, one with just A and one with just B, you get the series for ln 1 plus x for each. Now if you have a question on what I did. Yeah, it's a neat one, Fembox. Territar over in the YouTube chat pointed out that it's actually exactly the series for ln of 1 plus x, which does not have the factorial. And once you realize that, you're really just using log identities and the relationship that you helped find between A and B. Yeah. Let me look at what Waffle put it in the Discord. Waffle played me? Dude, that drawing of Zach is so good too. Yeah. I'm gonna add Zach. Giving me Scrabble proudness for me. That's awesome. Let's look at Critical's problem. Oh, I'm so sorry, Moses. I saw your message and I forgot to acknowledge it. I'm a senior in high school. I think I might be able to solve this problem in like 1 hour. Is that bad? I'm in my country. They don't even teach you problem solving skills. For a senior in high school, that's not bad at all. You are here, Critical? Okay. Like, even for like, if Fembox didn't tell me the trick here with using the tangent identity, I would have been solving this problem for so much longer. And if Territar didn't help me with the series for log, if I was doing this blind on my own, it would have taken me so much longer. So yeah, Moses, I would not, like, 1 hour doing it on your own blind is actually not bad at all. Arrows on an XY graph. Oh. Interesting. So, is there a part of this that you don't get critical? Like part in particular? Hey, fighting Roxisa Gamer? Probably saying that wrong, but I'm in America. You did it, but you're not sure if you did it right. Check the old note. It's quiet. It was quite different. Okay. Let's work it out then. Moses, you're in Iraq? Wow, I don't think I've ever met anyone from there. Welcome in. Oh, and Gold, isn't there something here where the cross product gives a volume? I think that's like, I remember Zach was actually just doing a problem like that on his stream. I think it's like for like a three-dimensional, it's called like a parallelepiped or something weird, like a parallelogram in 3 dimensions. It's like you have 3 vectors and you cross 2 of them and take the result and dot it with a third or something like that, and it's a volume. I can never quite remember it, but it's something like that. I don't think we'll need that here. Goodbye, marker. Let's go blue. All right. So U is 3, 2, V is 2, 3. We need to graph U, V, minus V, minus 2V. U plus V and U minus V. Okay. So we're going to need to go out, let's just call it 6 in every direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so for the first two, just doing U and V directly, that's a bit more direct, I guess. So if U is 3, 2, we go out 3 on the X. We go up 2 for the Y, right there, but it's a vector, so we make an arrow. We don't just do a dot. For V, we go to the right 2 and then up 3. I should probably label these. That's U, that's V. We need to do minus V. And so if V is 2, 3, then minus V is -1 times the vector 2, 3, which is the vector -2, -3. The -1 just gets multiplied to the top and to the bottom. So -2, -3 means you go left 2, down 3, like that. And that's minus V right there. And this V and minus V, they should be pointing in exactly opposite directions. Like they should make a straight line. Because no matter how you scale V, like no matter if you make v like bigger or smaller or reverse the direction, it should always make a straight line like that. And we'll see it here in the next one with minus 2v. We do minus 2 times the vector v. So minus 2 gets multiplied by each part of the vector, so minus 4 minus 6. So we go to the left 4, down 6 to go right there. If my scaling was, or if I drew my tick marks a bit more evenly spaced, it would be more clearly like all in a straight line, but all three of these v vectors should be on the same like straight line. Now we need to do u plus v. So we do 3, 2 plus 2, 3. So we add across the top and add across the bottom, and we get 5, 5. So we go to the right 5 and we go up 5 to go right there. Something like that. And then we need to do u minus v for the last one. You need to start it from 0. Yes. In linear algebra, your vectors pretty much always start from the origin. I think it's just a thing about linear algebra. Like in physics, you all the time would take that vector and like move it around over here, and like imagine like, you know, like some kind of like seesaw. If you have the same force vector, let's just say like, you know, you have a kid sitting there, or you take the same kid who weighs the same amount and you make them sit more on the end. It's the same vector, but where it's placed on the seesaw is different. In linear algebra, you don't worry about any of that. You just always start everything from 0 for whatever reason. But you don't, in the real world, you don't have to start everything from 0 is what I'm trying to say. That's not really like, that's kind of like a non sequitur, but yeah. U minus v, we do 3, 2 minus 2, 3. Subtract across the top to get 1, subtract across the bottom to get negative 1. So we go to the right one, and then we go down 1, and we get that vector there. U minus v. 2v needs to be connected with v. I think there's a better word than connected, because all these, like, every single one of these vectors that I've drawn are connected at 0, 0, like at the origin. But all these multiples of v, they should have the same angle relative to the x-axis. Maybe that's the better way of saying it. Like, what I'm trying to say is that this angle here from v to the x-axis is the same as this angle here from the negative x-axis to the negative v. And for the parallelogram bits, they don't ask you to actually do anything with it. They ask you to notice something. Wait, u minus v, did I do that right? Oh. That's a weird... They're saying to notice that you get a parallelogram here in green. Which I thought they were going to go for a different type of parallelogram. But there's probably an explanation for that I don't know off the top of my head. Because the problem said it is. I actually don't know why that. I don't know why that would be a parallelogram exactly, rather than some type of four-sided shape where the sides might not be parallel. I was just going off what the problem said for that bit. There's probably a better explanation on Google. Oh, well. Wait. Oh, it's minus. No. I did this wrong. I read that minus v right there as plus v. That makes way more sense what they're saying now. Okay. Let me redraw it. Who's that? I like a PC. Thank you for the follow. I'm not able to grab markers. I appreciate you following someone who isn't even able to grab a whiteboard marker. Okay. The parallelogram that you actually get, the vertices are 0, u minus v, and minus v. And the reason that we know that is let's talk about vector addition first. If you have any two generic vectors. Oh no, the blue marker is dying. Didn't I replace this recently? No, I replaced the red recently. Let me do it in red. You have any two generic vectors a and b. The sum a plus b is whatever vector makes kind of like the fourth vertex of this parallelogram with a and b. So this is like another b vector right here. That's like another a vector right there. So the sum is defined as like the diagonal, basically. And you can extend this to subtraction, which is the point they're trying to make here with u minus v, because what is subtraction if not adding a negative thing? So we could say that a minus b is the same as a plus negative b, and apply the exact same rule here, and it'll end up being subtraction. So we have our, oops, let me try and draw it. Let me try and draw a basically the same way that I drew it there. And we would have a b vector going up like there, but we actually are international now minus b, so we flip the direction. And so the sum of a and negative b is still whatever makes that diagonal. I should make that a solid line. So it's like we have another minus b vector there and another minus a, or in another a vector there. I didn't quite draw it to the proportion, but so it's the exact same thing as with addition, but subtraction you just have to flip the direction of one of the vectors. what is u comma 0 here? Like, you're asking what that is? U is the vector they give you. 0 is the 0 vector. As is negative v. They're saying that the ends of each of those vectors form a corner of your parallelogram. It's a list of different types of vectors. Yeah, and they're making the point that the u minus v is your fourth corner of this parallelogram. Exactly, yeah. They're making the point that it's going to end up being included. If you made the parallelogram only thinking about like 0 is one of your corners, the end of u is one of your corners, and the end of v as one of your corners, the fourth corner is always going to be u minus v. I think that's what they want you to realize. Like if you only had the other three, your fourth one is always going to be their subtraction. And Joseph, I mean, if you want to redeem something, feel free. The point they're trying to make is that if you're given a list of vectors, not fractions. And you were asked to make the parallelogram starting with these three things, you'll find that the fourth one is always going to be u minus v. That's like the realization that they want you to make, I think. No worries. Day after tomorrow is your first exam. Ooh, wow, good luck. Does GeoGebra do vectors? I hardly know how to work this website. Maybe if you made a point, you could transform it into a vector. Wait, show trace? No? Don't show trace. Okay. If it does do vectors, I don't know how. Yeah, anyway. Okay, so S sub n is a symmetric group of degree n, and they use the word degree because the order of this thing is n factorial. It consists of all integers from 1 to n as the set. Well, it's a set of all permutations of that. What's that? Oh god. If you redeem it, I'll try it. All right. I think I've been asked to draw the flag itself before, but this is a more creative version of it. I don't know how it's gonna work out. Okay. Flag. I guess I should figure out how much wiggle room do I have with the board. Like, put a dot there. Is that being blocked by chat? No. Okay. I think I'm already off to a bad start. Only made 2 lines. Starting with the front leg. Okay, got a little belly there. Got a big old leg. Huh. A little tail. Okay, that's not the worst body in the world. But now we have to get to the heads, which is going to be where this really goes to shit. Okay, so on top we gotta have me like screaming, ah, and then on the bottom we have me just kind of looking down. Hmm. Okay. Maybe I'll start with the lower. I mean, this is just gonna be weird. I don't know. This is messing with my mind. Just draw a circle. We have to start somewhere, right? How do you, how do you draw like a growling face? There we go. That's not terrible, right? So far? Now let's back up some of these lines so I can get hair and beard in there. I should probably have pupils, right? That'd be a good thing to have. Angry eyebrows. Okay, that's one head down. Oh, this one is going to be even better. I can already feel it. Oh my god. They came out kind of tiny. My two heads. I don't feel brave enough to redraw them though. We should get a little bit more detail on the body here, I think, too. Do a little bit of claws. Maybe that leg connects in a bit more of a natural way. Maybe. Do like a tiny bit of shading. I feel like I'm going to make it worse with this though. Okay. You know, I try to match the lighting that's in the flag. Sorry, we need to put this in caps. Oh no, I didn't leave room for the star. It'll be okay. Just slam it in there. No one will notice. There we go. Perfect. Thank you for the redeem there. I don't know if it'll work if you put something after. Maybe it'll still work. Okay, yeah, I think it just throws out anything you put after the clip. All right, cycle notation. Yeah, because of the way that Twitch works, a clip command will only ever do the last 30 seconds. It's kind of stupid they don't let you like customize the time or something like that. But if you want to like really get a clip and get like the start and end of it good, you have to use Twitch's like clip tool, and it's kind of annoying to use it. Honestly, I'm tired. I think I might just wrap it up here because I'm like, I don't feel like doing math now. Yeah, I think let's wrap the stream up for the day. So I'm gonna end the YouTube stream here on Twitch. We'll raid out Power of the Dude Dawn Republic. Yeah. So anyone who's here on YouTube, I appreciate you. I'm back on YouTube on Thursday.